Evet. Sesim geliyor desem diyorum arkadaşlar. Mesaj bana yazabilirsiniz. Seste herhangi bir sıkıntı oluşursa. Ekran paylaşımını yapayım. Ekran paylaşımını da yaptım. YouTube'da canlı yayında bağlanıldı açık bir şekilde. Şimdi arkadaşlar ders İngilizce olduğu için bundan sonrasında İngilizce devam edeceğim. Herhangi bir altyapıda bir sıkıntı olursa seste kayma, azalma o zaman yine bana söyleyebilirsiniz. Sesim geliyor mu? Yeniden bir ses kontrolü. Ses, ses deneme, ses. Sesim geliyor diye tahmin ediyorum. Yine dediğim gibi herhangi bir problem olduğu zaman mesaj alanından, sohbet alanından bana yazabilirsiniz. Şimdi artık İngilizce olarak devam ediyorum. Hello everyone and welcome to our course this semester. My name is Ramiz Görkem Birdal from the Department of Computer Engineering, and I will be teaching this class together with you throughout the term. Our lessons will take place online every week at this time, 12 p.m. So please make sure to regularly join these classes. There will be two exams during the semester, one midterm and one final. They will have equal weight in your overall grade, 50% for midterm exam, 50% for final exam. If you have any other questions, you can always contact me by email and I will be happy to help you. Also, please remember to check both the Canvas and Axis platforms regularly for announcements, updates, and course materials. I look forward to working with all of you guys and wish you productive and good semester. Now, in our Fundamentals of Artificial Intelligence course, in the first few weeks of this course, we will focus on understanding what artificial intelligence actually is. Not just a simple word, but as a scientific field with real-world impact. Before we go into technical concepts, algorithms, or models, we need a strong fundamental foundation of AI. So we will begin by exploring the basic idea of intelligence in machines, how AI differs from traditional computing, and how it has developed over time. This will help you see AI is not just as a tool, but a transformative force across industries, research, and daily life. As the semester progresses, we will move beyond definitions and take a deeper look into where and how AI is used. We will examine its applications in areas like medicine, finance, education, transportation, automation, cybersecurity, and creative industries. We will also discuss the major subfields such as machine learning, deep learning, computer vision, natural language processing, and robotics. So you can understand the building blocks behind today's AI system. Our goal in this course is not only to teach tech concepts, but to build AI awareness and critical understanding. Whether you plan to become a developer, researcher, engineer, or simply an informed professional, you will someday interact with AI. It's definitely directly or indirectly. That's why we will also touch on important questions. How does AI affect society? What are its limitations? What ethical responsibilities come with the use of AI? Or can machines really think? Or are they only sophisticated pattern matchers? By the end of this course, I want you not just to know about AI, but to recognize its presence around you, evaluate it with a critical eye, and imagine where it might take us next. This is not a course just about technology. It's about this course about the future you are stepping into. Okay, now let's change the page. And introduction to artificial intelligence, the first page. This section provides a foundation understanding of AI by explaining what is, how it evolved over time, and why it has become essential today and for the future. Because the importance of AI will getting higher by the months, by the years, and we will need to catch the importance and use it as much as we can. Okay. The next page is the definition and scope of AI intelligence. Okay, when we say AI intelligence or simply artificial intelligence or simply AI, we are talking about computer systems that can do things that normally require human intelligence. And instead of just following basic instructions like older computer programs, AI systems can learn. They are not rule-based or algorithmic. They can learn from data, recognize patterns, make decisions, and even improve themselves over time. Think of it like the difference between a calculator and something like Siri or ChatGPT. Calculator only gives you an answer when you tell it exactly what to do. But AI can interpret language, predict outcomes, and adapt based on what it has seen before. So at its core, AI tries to simulate abilities such as learning, reasoning, problem solving, perception, and even creativity. For example, when Netflix recommends shows you might like, it's not guessing randomly. It has learned your taste by analyzing what you have watched before. When when your phone unlocks using your face, an AI system has learned to detect and recognize your facial features. And even spam filters in email, Google Mailbox, email apps use AI to distinguish between real messages and unwanted ones. One important thing to understand is that AI is not a single technique or one specific machine. It's more like an umbrella term that covers many different methods for making computers or machines intelligent. Some AI learn from huge data sets, like how ChatGPT was trained on large amounts of text. Others use sensors and cameras, the videos, like self-driving cars that analyze their surroundings in real time. In short, AI is about creating machines that don't just follow instructions. They process information, make decisions in a way that resembles human thinking, and even if the underlying mechanics are different. And let's take a look at main subfields of AI. When we talk about main subfields, machine learning, deep learning, we have to mention all of this in the next weeks, but in a short term, I will try to tell today what they are. And in artificial intelligence, first, it comes from machine learning. What's machine learning? There are algorithms that enable machines to learn from data and improve over time without being explicitly programmed. What does it mean, programs? Program means it's rule-based, algorithmic. You tell the programs what to do, and the programs does it exactly how you say to them to how you tell them to do, and nothing more. Exactly what to do. And in machine learning, it was the fundamental of AI. And then the deep learning comes after that. Deep learning is a subset of machine learning that uses artificial neural networks with multiple layers and deep layers to model complex patterns. In machine learning, the patterns was easy and a little bit basic, but in deep learning, patterns become more complex, and especially in images, in high volume videos, speech, or text. But the text getting bigger every day. So after that, natural language processing, NLP, comes with large language models. NLP is the technology that enables machines to understand, generate, and interpret human languages. The most known NLP, as you know, is the OpenAI. It comes with ChatGPT. And after that, computer vision is another subfield of AI. AI systems that analyze and interpret visual input, such as photos, videos, 3D videos, 3D photos, can be everything about the vision. And the last one, robotics. I believe robotics will be shining in 10 years because the integration of AI with mechanical systems to create autonomous or semi-autonomous robots capable of interacting with the physical worlds. And with that, robotics brings AI into a physical world. While a robot is just a machine on its own, it becomes intelligent when AI gives it the ability to sense its environment, make decisions, and act without direct human control. And warehouse robots that move packages, drones, or navigate on their own, robot surgeons assisting medical procedures, and humanoid robots like Tesla's Optimus are all real-world examples of how robotics and AI come together. All of these subfields often overlap. For example, self-driving car uses computer vision to see road, machine learning to interpret what it sees, and robotics to control the vehicle in the same way. AI assistant uses NLP to understand your request, and machine learning to generate response. Together, these areas form the foundation of modern AI. And when we look at the modern AI, what's the options we can use in modern AI? Artificial intelligence, as you know, is no longer a futuristic idea. It has become part of the everyday life, often in ways people don't even notice. One of the most familiar examples in virtual assistants like Siri, Alexa, and Google Assistant. When you ask your phone to set an alarm, play a song, or answer a question, AI is working in the background to understand your voice, interpret your meaning, and respond naturally. The same kind of intelligence appears in chatbots on websites that help you with customer service or answer your questions without needing a human employee. Another place where AI plays a major role is recommendation systems. Platforms like Netflix, YouTube, Spotify, TikTok, or Amazon all use AI to study your behavior and predict what you might want next. If you watch a lot of scientific movies, Netflix will suggest more of them. If you often listen to jazz, Spotify will automatically create playlists in that style. Even social media feeds like Instagram and Twitter show you posts based on AI prediction of your interests. Self-driving is another powerful example. Cars from companies like Tesla, Waymo, or others use sensors and AI models to detect roads, traffic signs, pedestrians, or other vehicles. Although fully autonomous vehicles are still being tested, many modern cars are already use AI for lane assistance, automatic braking, and parking guidance. Drones also that can navigate by themselves to deliver packages also depend on AI to understand their surroundings. Also, healthcare medical diagnosis. Healthcare is a field where AI is making life-saving contributions. AI systems can analyze X-rays, MRIs, and CT scans to detect tumors or fractures faster and sometimes more accurately than humans. Some models can predict disease before symptoms appear by looking for a subtle patterns in medical data. Doctors also use AI to design treatment plans personalized to each patient. Its personalized treatment plans comes very important in the next 10 years, and this market, I believe, will be top in next 5 years. So it's really important area. Also, financial institutions rely on AI as well. Banks use machine learning models to detect fraudulent transactions in real time by spotting unusual spending patterns. If you send someone a big amount of money and then you change your password, it's a really suspicious pattern. And when the AI catches this pattern, it will tell all the authorities about your moves because it's suspicious. Investment platforms also can use algorithms to make trading decisions in milliseconds. Even your credit score might be influenced by AI systems that analyze your financial habits, all your habits, and the outcomes with your habits, with the outcome of your habits, they can make it better your credit score or get it down because credit score is very important when you get credit from the bank. And also security and privacy also depend on AI. Facial recognition can unlock your phone or allow access to secure areas. Spam filters scan your email inbox and block unwanted messages. Also, cybersecurity tools use AI to detect hacking attempts and protect your network. Even creative fields are changing. AI can now generate images, music, code, even videos. Tools like Midjourney, Dolly can create artwork from text descriptions. ChatGPT can help write essays, explain concepts, generate ideas. Companies use AI to produce marketing content or design prototypes in seconds. In short, AI is not just part of high-tech labs or science fiction. It's about shopping, entertainment, transportation, healthcare, education, finance, communication. Most of people use AI every single day without even realizing it. Now, let's look at the historical development. How AI becomes so important in human life. AI didn't emerge suddenly. It evolved through key conceptual and technological milestones. The earliest ideas started before computers even existed. In the 1930s and 1950s, between these dates, these years, mathematician Alan Turing proposed something called Turing machine, which was a way to describe how any problem could be solved with a machine if you gave it the right instructions. And this idea became the foundation of computer science. Later in 1950s, Turing came up with the Turing test, a simple question. If you don't talk to a machine through text or can't tell if it's a human or not, can we say the machine is intelligent? I repeat it. If you talk to a machine through text and can't tell if it's a human or not, can we say the machine is intelligent? That question shaped how people thought about AI for decades. And the official birth of AI is often linked to Darmo Conference held in 1956. A group of researchers, including John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester, gathered to discuss how machines could simulate human thinking. It was at this event that the term artificial intelligence was used for the first time in 1956. At the time, researchers were incredibly optimistic. They believed that human-level intelligence in machines might only take a few decades. In the 19 and in the 1970s, the first experimental AI systems were created. One famous example was ELIZA, a simple chatbot that pretended to be a therapist by repeating parts of what people said. Even though it hadn't actually understand language, many people were surprised at how human-like it felt. Around the same time, scientists built expert systems which tried to copy the decision-making of doctors, engineers, or other specialists using handwritten rules. But there was a big problem. As soon as the situations become complex, these systems couldn't adapt because they didn't really learn. They just follow the instructions, rule-based instructions. By the late 1970s and early 1980s, AI faced disappointment and funding cuts, which led to what people call the first AI winter. First AI winter between late 70s and early 80s. There was no progress about AI. All the researchers stopped. There were budget cuts. So we call it first AI winter. Researchers had big goals, but the technology and computing power weren't strong enough yet. I'm not talking about software, I'm talking about hardware. Hardware of computing power were not strong enough yet. And things improved again in the 80s and 90s when new ideas like neural networks probabilistic reasoning, bias in models, and support vector machines appeared. These allowed systems to handle uncertainty and learn from smaller datasets. AI started to be used again in speech recognition and basic pattern recognition. A major breakthrough happened in 1997 when we faced with Deep Blue, when the IBM system Deep Blue defeated Garry Kasparov, the world chess champion at that time. This was first time a computer beat a human world champion in such a complex game. And it shocked many people, but the real revolution began in 2010s with the rise of deep learning. Around 2012, a neural network called AlexNet dramatically improved image recognition accuracy and kicked off the deep learning era. Just a few years later, in 2016, Google DeepMind's AlphaGo beat Lee Sedol, the world champion in the board game Go, which is much more complex than chess. From 2018, from 2018 onward, we entered the age of modern modern AI area. And large language models like GPT or BERT started understanding and generating human language at levels we had never seen before. AI also began to show up in robotics, medical imaging, self-driving cars, generative art, autonomous decision making, and something like these systems. And the systems like ChatGPT, DALL-E, Copilot, and Midjourney become widely used all over the world, showing that AI was no longer just a research topic, but part of everyday life. Today, AI is moving faster than ever, and we are living in a time that previous generations of researchers only imagined. And let's look at why AI matters today and where it's going to the final destination next. Artificial intelligence has become so important today because it's no longer just a research topic or futuristic concept. It's something that actively shapes how industries work, how decisions are made, even how we live our daily lives. In healthcare, AI helps doctors detect diseases earlier by analyzing medical scans with impressive accuracy. Some hospitals use AI to read X-rays, diagnose cancers, and even predict patient risks before symptoms appear. In education, another field, AI powers adaptive learning platforms that adjust lessons based on each student needs. If I need math class, I will take math class. Not a poetry or science class. I don't need them. And AI can find what you need. Apps can now summarize textbooks, generate quizzes, or act as a personal tutor. Finance, the third topic, is another sector, as I mentioned just before 10 minutes ago. Transformed by AIs, banks use to detect fraud by catching unusual spendings. AI algorithms make lightning fast trading decisions and something as I mentioned before. But AI just not about automation. It's also about creativity and problem solving. Tools that generate images, videos, music, even code are already being used in marketing, design, filmmaking, gaming, software developments. AI assistants like ChatGPT or Copilot help students to write essays, programmers fix bugs, and businesses speed up their work. Looking toward the future, researchers are aiming artificial general intelligence, a type of AI that could think and learn across many different areas, not just one. If that becomes real, we might see systems that can reason, plan, and adapt like humans. There are also developments in brain-computer interfaces where AI could move, AI could connect directly with human nervous system to help paralyzed patients to move again and enhance human capabilities. Another frontier is the combination of quantum computing of AI, which could allow machines to solve problems so complex and that today's computers can't even begin to process them, because quantum is really different and one of the most famous areas in computer systems. Quantum is the feature when you have capability to solve the questions, and your improvement will get faster. And problem solving is about just quantum computing. It's getting better every day, and maybe in 4 or 5 years, quantum computing will break many problems, many passwords and password algorithms, and also it will also open a new door to the future of computer systems. So quantum computing is really something matters about computer intelligence and computer engineering. And of course, with all these advancements, there are also serious concerns. People worry about AI taking over jobs, job displacement. These are the outputs of AI ecosystem, especially repetitive or data-heavy ones. The jobs, especially repetitive, when you do the same actions during your job, during your working times, it calls repetitive. If you have a job repetitive and data-heavy one, AI can take over your job. And data privacy is another issue, data privacy. How much personal information should AI systems be allowed to access? There is also the risk of bias in AI systems. If they are trained on unfair or unbalanced data, the outputs would be bad for for your decision, because unbalanced data can trick AI. Governments and also organizations around the world are now working on laws, standards, and ethical guidelines to make sure AI is used safely and responsibly. In simple terms, AI is becoming foundational technology. We all accept this, similar to electricity or internet, something that will influence almost every industry and profession. But the real question is not whether AI will shape the future, but how we choose to shape AI. And now let's start with section key, AI and the human brain. Now, the topics in the section is human brain versus artificial neural networks, cognitive imitation efforts, intelligence versus consciousness, and the last one, brain-computer interfaces. Now let's start with brain and artificial neural network, the fundamental of AI. People often assume artificial neural network work like the human brain just because the names sound similar, but they are fundamentally different in both structure and behavior. The human brain contains around 86 billion biological neurons, each connected to thousands of others. And these neurons don't just transmit information, they reorganize themselves, strengthen or weaken connections, and even form new pathways depending on experiences, emotions, and environment. For example, you can smell a specific perfume and suddenly remember a childhood memory. Your brain links senses, memory, and emotion in ways AI simply can't. Artificial neural networks, on the other hand, are mathematical approximations. When you get closer, we call it approximation. Mathematical approximations, not biological systems. They don't grow or rewire themselves in the organic sense. Instead, they adjust numbers called weights during training. When you train an AI model to recognize cats, it has to look at thousands or even millions of labeled images before it performs well. A child can recognize a cat after seeing just one or two. Similarly, humans can transfer knowledge between tasks. You can learn to ride a bike and then and the more easily learn to ride a scooter. If you know how to ride a bike, it's easy to learn how to ride a scooter. But if you train an AI to play chess, it cannot suddenly play checkers or poker without being retrained from scratch. Another key difference is energy efficiency also. The human operates on roughly the same power as a light bulb. It's about 20 watts. While training advanced AI models often requires massive energy consumption through specialized GPU clusters. Uh, the brain also operates in real time, integrating visual, auditory, sensory signals instantly. In contrast, AI models need preprocessed digital unit and still struggle with ambiguity. For instance, if a handwritten A looks messy, a human can guess its meaning instantly, but an AI model might completely fail unless it has seen similar shapes during training. Emotion and intuition are also areas where the brain outperforms AI. Brain outperforms AI, emotion and intuition. A person can sense when someone is upset, even if no words are spoken. The awareness comes from subtle cues, memory, and empathy. AI can analyze facial expressions or tone of voice statistically. It doesn't feel anything. It doesn't get nervous before a test or excited about a goal. Humans make decisions only based not only on logic, but also on cultural values, experiences, and emotional context. Meanwhile, AI follows its training data and mathematical optimizations, nothing more. To put it simply, the brain is a constantly evolving, self-healing, multi-purpose system shaped by biology and experience. Artificial neural networks are powerful tools, but they are static mathematical constructions designed for narrow purposes. They don't dream, imagine, improvise, or reflect. They only compute. Uh, Now let's talk about consciousness. Consciousness. Consciousness means cognition. Uh, it's about knowing or learning something. Uh, but first, I forgot to mention about cognitive simulation, the second one. Let's keep going with cognitive simulation, and about after that we will come to consciousness. Cognitive simulation, one of the biggest goals in AI, has been to imitate human thinking, especially how we understand language, learn from information, and make sense of the world. AI models like GPT are impressive because they can generate fluent sentences, answer questions, translate languages, writing codes, and even mimic different tones and different writing styles. But it's important to understand how they do it. They don't think the way humans do. They simply detect patterns, and for gigantic amounts of text, when you ask a question, the model doesn't understand it the way a person does, but it predicts the most likely next words based on its training. For example, if you ask GPT to write a poem or summarize a book, it isn't recalling memories or emotions. It's combining learned patterns in a statistically meaningful way. That's the only thing they do. Humans process information in a completely different manner. When you hear a joke, your brain connects prior knowledge, emotion, culture, and logic to interpret the meaning. When someone gives you directions verbally, you can imagine the space, remember landmarks, or even ask clarify questions. AI language models, on the other hand, don't have a grounded sense of the world. If a model says Paris is the capital of France, it doesn't know where Paris is. It has just seen the sentence frequently in its training data. Another major limitation is an abstract and conceptual understanding. For example, if you ask a person to invent a fictional creature based on combining a lion and a fish, they can picture it mentally and describe how it might behave or survive. An AI might generate a description, but it doesn't imagine anything. It recombines language patterns it has already encountered. Humans can also reason with missing and incomplete information. If you tell a child the glass on the edge of the table and the cat is jumping, they can intuitively guess that something might fall. AI models struggle with the kind of inference unless they have explicitly seen similar situation many times. Even in problem solving, AI is limited by the boundaries of training. A student who learns algebra can often apply those principles to physics or programming. AI, on the other hand, usually has to be trained separately for each task unless it has been built as a large general model. And even then, its understanding is shallow. For example, a model can generate computer code that works, but it doesn't actually reason through the logic the same way a programmer does. It predicts code patterns rather than planning internally. There is also no sense of intuition, curiosity, and self-correction in the human sense. When a person gets something wrong, they might feel uncertain, reflect on their error, and improve based on experience, but AI doesn't realize that it's wrong. It only adjusts when developers retrain it or provide feedback through reinforcement learning. These are all terms about AI. I will explain reinforcement for learning. What is this in the next courses, in the next few weeks? But now I'm just telling about the fundamentals. Even hallucinations when AI gives confidently wrong answers are proof that it lacks real comprehension. In short, AI can simulate certain cognitive behaviors well enough to appear intelligent, especially in language-based models, but simulation is not the same as understanding. AI uses statistical correlations, while humans use meaning, experience, imagination, and reasoning. The gap is still huge. And I am passing to next, intelligence without consciousness. This is the important problem. I will explain it. Well, one of the most confusing things about AI today is that it can sound intelligent, okay, solve problems, even outperform humans in some areas, yet it has no awareness, no feelings, no inner experience. When we call AI smart, we are really talking about its ability to analyze data, detect patterns, and generate useful responses, but intelligence is not the same as consciousness. A calculator can instantly compute large numbers, but nobody thinks it understands math. In the same way, an AI model like GPT can write essays, translate languages, or generate medical advice, but it doesn't actually know what it's saying. It doesn't care if the answer is correct, helpful, or harmful. It just produces output based on probabilities. Humans, in contrast, think with intention, awareness, and emotional context. When a person gives someone advice, they might consider feelings, consequences, cultural norms, and moral responsibility. AI does none of this. If an AI generates a poem about love, it doesn't feel love. If it gives legal or medical suggestions, it doesn't understand the risks. Even when AI apologizes, I'm sorry I made a mistake, that's not genuine emotion or reflection. It's just a pre-trained response pattern. To make this clearer, imagine three scenarios. A human doctor considers a patient's fears, health history, and ethics before making a recommendation. But medical AI system analyzes only data and statistics without caring about how the patient feels. A human writer creates a story based on imagination, memory, and creativity. An AI language model generates a story by combining words it has seen elsewhere. A human might lie for personal benefit or stay silent for moral reasons. An AI lies only when its training or prompt causes it to generate incorrect information. It has no concept of honesty. AI doesn't know honesty. Because of this, AI has no self-awareness. It doesn't know it exists, self-awareness if it exists, doesn't experience time, doesn't form opinions, and doesn't reflect on its own limitations. It cannot feel guilt, pride, curiosity, jealousy, or empathy. It doesn't dream, hope, or fear. Even when AI beats a human player in chess or Go, it doesn't celebrate. It has no understanding of winning or losing. To the system, it's just optimizing numbers. This leads one of the biggest debates in AI. Can machines ever become conscious in the future or in the near future? Some researchers believe future AGI or SAI might eventually develop awareness if their cognitive complexity surpasses a certain threshold. Others argue that consciousness is tied to biology, embodiment, or subjective experience that can emerge from code alone. So far, there is no specific scientific evidence that AI system has even the slightest form of consciousness, zero consciousness. What we have today is functional intelligence without inner life. AI can simulate reasoning, but it cannot feel. It can generate options, but it cannot believe it. It can answer personal questions, but it has no self. That's why AI can be incredibly powerful and also potentially risky because it operates without judgment, morality, or understanding. And the last one is about brain computer interfaces. Interface is another computer term, uh, but day by day we will get closer of these terms and I will understand what is the meaning of these terms. Interface is something facing with another system. Brain computer interfaces, or BCIs, are one of the most fascinating frontiers where artificial intelligence and neuroscience meet. The basic idea behind BCI technology is to create a direct communication link between the human brain and the machine without needing speech, touch, or traditional input devices. Instead of using a keyboard, a joystick, or a touch screen, a person could potentially control a computer or robotic device just by thinking. This could completely change not only medicine or communication, but eventually how humans interact with technology in general. Right now, one of the most active areas in BCI development is helping people with disabilities. For example, there are already paralyzed patients who can move robotic arms using implemented electrodes that read their brain signals. Some people with spinal cord injuries can type messages on a screen just by imaging hand movements. There are also EEG-based headsets that allow users to play simple video games, move wheelchair, or control cursors using basic brainwave patterns. While these examples sound futuristic, they are already happening in labs and hospitals. Companies like Neuralink, funded by Elon Musk, are pushing this technology further by developing brain implants that can record and stimulate neural activity with high precision. Their goal is to help people who cannot speak, move, or see. Imagine a person with total paralysis being able to send emails, speak through a digital voice, or control a robotic limb directly with their brain. Another goal is restoring vision by sending signals from cameras to directed to the brain, bypassing damaged eyes. In clinical trials, early versions of these implements have already allowed monkeys to control a computer cursor telepathically and pigs to share brain activity data in real time. But BCI is not limited to medicine. Some researchers imagine a future where healthy people also use BCIs to enhance memory, accelerate learning, or interact with augmented reality without screens. Imagine preparing for an exam by uploading information directly to your brain or communicating with someone silently in another country. Some even talk about neural keyboards where you compose messages or code without touching a device. Just by thinking the sentences in your mind. There is also conversation about hybrid intelligence where AI and humans can work together seamlessly, merging biological thinking with digital computation. Of course, these developments come with serious ethical questions. Who controls the data coming from your brain? What happens if someone hacks or manipulates a neural implant? Could BCI change personality, emotions, or identity? Would only wealthy people have access to upgraded intelligence? There are debates about privacy, inequality, mental autonomy, and even whether thoughts could eventually be monitored, predicted, or influenced. Despite these concerns, the potential benefits are enormous. BCIs could give independence back to millions of people with neurological conditions. They could allow soldiers, surgeons, or astronauts to operate equipment with unprecedented speed and precision. They could even provide new forms of art, communication, human exploration, human expression. In the long term, combining AI with BCIs might blur the line between technology and biology in ways human has never experienced before. Uh, Actually, this week I will stop from here, and the next week we will discuss another topics. During this semester, I will give many examples about artificial intelligence, and we will try to understand what is AI, what's the scope, what is the history, and what is the math and probability for an AI. And after that, I will mention about what is data, what is learning, the supervised and unsupervised AI, learning techniques, and later then maybe a representation of these deep learning or learning techniques. And after that, maybe I will mention about the logic behind this AI, especially interdisciplinary relations with other disciplines, because AI comes cooperative with any discipline in the world. And after that, we will look deeper in the AI systems, the designing of AI systems. But after fundamental is done, we will keep talking about deeper topics like unsupervised learning or representation learning or LLM or transformers or some other CNN for images, some other topics. But as I mentioned before, the most important thing is giving you awareness about AI and learning about the fundamentals of AI and learning about how to use in your career the AI tools to promote, to become more, to have more ability in your career, because it's really important to know how we are supposed to use AI tools. And after that, also I will share my PowerPoint with you guys, and also I will share some documents to study in your midterm exam and final exam. All written notes will be given to you. Don't worry about it. But now we have 6 or 7 weeks until the midterm exam, and we will talk about all these topics in detail. And after that, when we close to the midterm exam and final exam, I will share with you the resource notes to study for your exam. And if you don't have any questions, I will finish this course for this week. And next week, same day, same hour, we will meet again. I will keep talking about AI. And during this week, if you have questions, you can email me, or if you miss the course, you can watch it on YouTube. Don't worry to watch it regularly, because when the exam comes, I don't want you to have many videos to watch, because there will be no time to check it out, all of them. I will recommend you to follow the courses regularly. And I think for the first course is enough. Thank you for your contributions, and thank you for everything. See you